All right, so correlation R we're talking about today measures both strength and direction of the linear relationship. It does not necessarily mean the distribution is actually linear. So you have to look at the scatter plot, all right? So raise your hand if you guys remember anything about R. Like, what do you guys remember about R? Ginger. Yeah, the closer it is to +1 or -1, right? The stronger the linear correlation is. Okay, Jake?
If the correlation coefficient is negative and it's close to 1, they're inversely proportional.
Okay, yep, there you go. Good. Okay, so the positive negative does make a difference, right? If it's a positive R value, what does it mean about the points? What do they look like? Up, right? Rise right. Okay. And the negative R value, the points should kind of fall. All right, so just remember, you could have a strong R value, really close to 1, and the pattern may not be linear. So your points could be this like curve where like if I drew a line, it's kind of linear-ish, right? The R value might be close to 1, but you would not want to say it has a linear pattern. Okay, so that's the one thing you want to watch out for in this section. Also, we can't always use our eyes to find R. This is actually the exact same scatter plot. Right? One of them is just closer than the other one as far as your window goes. So just be careful when you're looking at R that you're not always assuming anything. So here's a couple things to remind you about correlation. This one's 0. So if R is close to 0, the points have no linear correlation. There's just like a random scatter plot, right? So you might want to draw a few of these pictures. If we've got -0.3, this actually has some negative correlation right here. So you might say a weak negative correlation. Okay? So both strength and direction can be determined, right? And this next one, we've got a somewhat positive, even though it's only 0.5, there's still a little bit of positive correlation here. So you might say somewhat positive. We're not going to have exact cutoffs, you guys. Like from here to here is exactly these words. So you just have to use what you think, okay? Is it weak? Is it somewhat? Or is it strong? All right. -0.7, fairly correlated. Okay, we've got negative correlation here. I don't know that I would say strong, but fairly. Okay, moderately maybe is a good word. Moderately negative. And when you get to the 0.9s, that's definitely strong. Okay, strong positive. This right here, really strong. Okay. So just for fun, we're gonna practice and see if you guys can guess some correlations. All right, so let's start with this guy right here. What do you guys think? 0.79? All right, how about this guy? What? That is ridiculous. Okay. And how about this one? What? Which one of those looks closer, you guys? So this one, -0.8. All right, I don't know. We'll guess. What about this? 0.3. Okay, still kind of positive. What? You guys got it. Boom. All right, let's try one more. How about this one? Okay, how about this one? Okay, how about this one? Tuffy. Okay, compared to this one. This one has more outliers. So you guys think 0.44? All right. You guys All right, way to go. All right, so let's do an actual what you might see here. So back to the SEC football that we were looking at, where we had points per game and number of wins. This time they're going to give us the R value, so that's nice. We've got a scatter plot for these data. R is it's hard to read, 936. All right, interpret the R value in context. So again, always in context, you guys. That's the hardest part. Yeah.
You want me to do it?
Yeah, go for it. What do you think?
So there's a strong direct proportionality between points per game and wins.
Okay, I agree. So we're going to say there's a strong positive linear relationship. You have to include the linear part between points per game and wins. So go ahead and write that out, even if you think you already know it. There is. Okay, strong positive because we have 0.9. That's always going to be strong positive. And then don't forget linear because the points are actually linear. Okay? And basically, you guys, this R value confirms what we already know by looking at the scatter plot. All right, part B, the point highlighted in red. That's this point right here. It's Mississippi. What effect does Mississippi have on the correlation? Anybody else have an idea what effect, if we took it out versus when we put it back in, what it does? Does it help make a line or not? Make it worse? Someone besides Jake. You think it helps? That's right. So you guys, Mississippi actually makes the correlation closer to 1. If we took this point out, it's less linear. This point really helps line up with the line. All right? So Mississippi makes the correlation closer to 1. Okay, how to actually find R by hand. Yikes. So it's not actually that bad unless you have a ton of data points, and then it would be really not fun. So chances of you having to do this on the test are apparently pretty slim, but just in case, let's write this formula down. So R is equal to 1 over n minus 1. So R being the correlation, n being the number of data points. Okay, then we've got the Riemann sum. We're adding every single time the value minus the mean divided by the standard deviation. The only difference is here we've got two variables, x and y. And we have to multiply each one together. So the points that go together, multiply, and then you add between them. We'll do one of these. This formula is on your AP test sheet, you guys, so you don't have to memorize this formula. You basically want to be able to find R and know what that formula means, so hopefully, just in case you have to do it, you can. So this is some people's height and shoe size from this class. I only picked 5 points because I don't want to do a million of these, right, for correlation, just to show you how to do it. So first thing you always have to find is the mean and the standard deviation for each. We'll say this one's y. Okay. So I went through and did that, and so the mean height is 66.4. And the mean for the standard deviation for height is 5.4. Mean shoe size, 9. Standard deviation was 2.9. Now, I did have to round a little bit. Okay. So R is equal to 1 over n minus 1. So how many data points do we have? 5. So it's going to be 1 over 4. And then we're multiplying that by the sum of this craziness. So inside our parentheses is always the first guy minus the mean divided by the standard deviation. So 64 minus 66.4 divided by 5.4. And it multiplies times the corresponding y value. So 64 goes with the shoe size of 5. Miniature feet right there. 5 minus 9 divided by 2.9. Yeah, who's got shoe size 5? Okay, then we do the next point. We got to do a plus sign in the middle. Now we go to the next point. I'm running out. Normally this would go in one long line, but I ran out of room. So the next one is 73 minus the mean divided by the standard deviation for height, multiplied by the next data point, which is 11 minus 9 divided by the standard deviation, plus the next point, 71 minus 66.4 divided by 5.4 times the y value that goes with it, which is 12 minus 9 divided by 2.9. Right? So close parentheses. If you're ever showing work on the AP test, you are allowed to use ... after you show the pattern and you know what you're doing. Okay? And then, of course, we'd plug that all into our calculator, and we would get 0.559. Okay? So again, chances are slim you will have to do that by hand, but just so you actually understand the formula and can interpret it, hopefully you can use it if necessary. If you're asked to interpret a correlation, it is pretty much the same as DOFs. So the same as when you interpret a scatter plot, okay? So we won't go over that again, but it's pretty much the same. A couple facts about correlation. You should write these down because this is always like what they do the multiple choice stuff on. Make sure you understand some of that. Oh, 0.559. Yeah. All right, correlation makes no distinction between explanatory and response variables. If you switch your y and your x, it won't matter. You'll get the same R value. Okay. R does not change when we change units of measure. So remember when we switched from inches to centimeters, something like that, the R value is going to stay the same. So it'll correlate or not correlate the same amount, even if you change units. Okay, R has no units of measure. So the mean has a unit of measure, the median has a unit of measure, the standard deviation has a unit of measure. If it's all in inches, those are all in inches. But R never has a unit of measure. It is just a number. Correlation does not imply causation. So just because it appears to have a linear pattern doesn't mean that something actually caused another thing to happen. Correlation requires that both variables be quantitative, right? They have to both be numbers. Correlation only measures the strength of a linear relationship. So if you have a curved pattern, then we don't really need correlation to go with that because it's measuring only how linear something is. Same thing kind of as the last one saying a value of R close to 1 or negative 1 does not guarantee a linear relationship between two variables. They really drill this into your head in this book. So watch out for that on the AP test. Always plot your data. You have to look at the scatter plot. Don't assume just from the R value. Correlation is not resistant. What does that mean? We learned that a while ago. Jake, what do you think? Yep, if you put an outlier in there, that's going to definitely change correlation. So the closer the points are to the line, the closer the R value is to 1. And the last one, correlation is not a complete summary of 2 variable data. We also need to give means and standard deviations of both x and y along with correlation. All right, and of course, we have to remember how to actually find R. Some of you guys may remember how to do this already, but we're going to calculate R by the calculator. We just did it by hand where it was 0.559. And now we're going to calculate it on the calculator, which is more accurate because of rounding. So we're going to enter this into our listen spreadsheets, label height, and shoe size for your other list. We're only doing those 5 data points. And if you guys remember, you go menu, statistics, you can do it on the tables page. And when you guys get R, remember it's R and not R squared. They give you both. Let me know so I can make sure you guys know how to do it.